In order to make a good quality drumstick, we have to start out with good quality wood. Wood is not uniform, depending on where the tree grows, the soil conditions, temperatures it grows in, how much moisture it sees, how much light it gets. All those things affect the properties of the individual piece of wood. We buy wood straight from the sawmill in a rough square form. That allows us to control the drying of the wood inside the dry kilns. It allows us to control the way that you shape that dowel.
All right, what we're looking at is one of our kilns. Kiln is how we dry the wood. Basically what's happening is we're controlling the moisture content through heat, and we have baffles that actually direct the airflow. And as the airflow goes through the kiln, it goes in a circle, so it's dry air coming in and moist air coming out.
In order to dry hickory or maple in the kiln, it takes us about a 2-week cycle time to get the moisture content down to the level that we need. During the kiln cycle, we constantly take samples out of the kiln in order to check them for moisture content and stress.
One way to check the moisture content of the wood is to use a pin meter, which measures resistance within the wood. Hammer 2 electrodes into the stick. We hit a button, and it will give you a reading of what the moisture within the wood is. One way we check the stress on the wood is to actually cut the wood with a bandsaw to determine whether or not it's stressed. If it's stressed, it'll either open up or it'll close tight on the blade. And a stick with no stress will have a straight cut. It didn't collapse on the blade. It didn't open wide open. And that's what we're looking for every time.
So in order to ensure a uniform, high-quality stick, we have to ensure that we have uniform, high-quality wood, and that all is controlled inside the dry kiln.
The first machining process we're going to take is putting it in a machine called a molder, which will take a cleaning cut off of all 4 sides and actually square the bar. First time the bar gets inspected is at the loading station for the molder. One of the things that the first inspection is looking for is warpage for the bars. Things that we know either will jam the machine or not make a good drumstick. This is an example of too much stress. Once it gets this bad, no amount of machining is going to get it out. So we take it out of the process up front and don't try to force a drumstick out of it. From the cleaning cut then, we're going to put it through a device called a doweler, and it's going to change form from square to round. On the doweling machine, it's going into an indexing conveyor where we have a weight scale set up and also a laser micrometer. So we're measuring the run out on the dowel, and we're also weighing it. Any stick that is too light to make a good drumstick, we're kicking out of the process before we even grind a profile. We do a classification step at the end of the process where we're looking for things like mineral streaks, knots, cross grain, and we're doing an orientation of the best grain to be on the tip. We use a centerless grinding process to form the profile for our drumsticks, and the first step in that is to make a metal template from the CAD drawings. We'll burn in the actual profile of the stick. What we're doing is we're transferring the profile to the grinding wheel so that when we place the dowel into the grinding machine, it's grinding the exact template. First stage of the process is using the grinding wheels to form the shape of the butt. After the butt is ground into the stick is transferred into the second machine where the same grinding process will cut the profile of the tip. Our operators are checking sticks at a very frequent interval. And we use vernier calipers and micrometers in order to ensure that we're meeting the very close tolerances that we demand. We're using an injection molding process to apply our nylon tips. The plastic is heated and melted, and it flows through this distribution channel called a runner system, where it's injected then into the cavity, which forms around the wood ball. And the end result is you have the plastic encapsulating the ball, and it's very strong and it won't break. We're actually using a specially formulated high impact material, so it's guaranteed not to break, and the wood will break before the tip will break. This is our dip finishing room. The processes that are employed here are either a tumble finish, where we'll put the clear lacquer on a drumstick, or in the case of our signature sticks that have a dip coating on, we have a dipping process to put that colored top coat on. Here we're dipping a Steve Gadd stick. In order to have a nice looking finish and prevent air bubbles, we have to have a controlled exit from the tank. In this room, after the sticks have been finished, we're going to put our logo on them, we're going to weight sort them, tone pair them, randomize them, sleeve them, package them, and get them ready for shipment. So after the sticks have been pad stamped, they go through a small oven which cures the ink. From there it goes directly into another computer-controlled laser straightness checking device. So every stick is checked by laser to make sure it's perfectly straight. After the sticks are stamped, they come to this machine, which is our weight pairing machine. Every stick goes across a scale. The stick is weighed, and the computer assigns it a bin location based on its absolute weight. Each of these bins are within 2 grams weight of each other, so we have 2 grams of separation. The sticks that came off of the weight bed are grouped by absolute weight. We bring those sticks over to our next machine, our tone pairing machine, based on those weight groups. The sticks are being presented to an anvil, and a hammer is striking it, which is creating a resonance. We have a computer that is measuring that resonance. We're able to analyze the digital signal then and get the frequency response spectrum. You'll see the graph on the video screen. It then tells us an absolute average frequency response for that stick or tone. The computer then will again assign it a specific bin location based on what that tone is, and the end result is you have the same weight stick, and now they're matched by frequency response. Based on the number of bins that we have in this machine, we will have some sticks that aren't quite up to the frequency for the diameter of stick that we're running. Those will fall out into the first bin, and while there aren't many, we do get a few. These particular sticks then don't have the tonal characteristics that we're looking for, and so they will not go through the process and be sleeved. We have one additional opportunity then to inspect the sticks. Our operators are looking at the sticks in the bin, matching them by color. So now we have the same weight, the same tone, the same color, and we'll preserve that match by putting our matchbook sleeves on the sticks at this point in the operation. And as no two drummers are alike, we like to provide variety. So we'll take a variety of weights and tones that are all matched, and we'll mix them up on a table. We'll apply our label to them, and then they'll go over to our bricking operation where we'll put them in bricks of 12. We're putting a strapping on it to hold the brick together. It goes through a hot air oven, which causes the film to shrink tightly against the brick, and when it comes out the other end, it's a nice integrated, tight package that can be placed in a box without fear of it breaking apart.